out. I'm going to try to pick ones that are different from this morning. So in case anybody wants to go back and watch that morning recording, can have a different set. But I'm basically pulling from the same worksheet that I have on that chat box there. So, okay, so let's do this one here. Do we have dy dx? Okay. Initial condition, f of -3 equals 6. Okay. We want to solve for this differential equation. So first things first, I like to cross multiply. Okay, when I cross product, it doesn't guarantee that I get full separation, but I do get the dy and dx locked in to their right spots. So, okay, cross multiply. So after cross multiplying, do we have full separation of variables? Are the y's together on one side? Are the x's together on the other side? Okay, so we do have full separation, right? Y's are together, y dy together, x's, dx's are together. So we know that we're ready to move on to our antiderivative step. Okay, so take the integral of both sides. Okay, apply power rule. Okay, what does y become?
Y squared over 2.
Yeah, just y squared over 2. And right side is also power rule, right? What does 2x become?
Is it just x squared?
Yep, minus
X
plus c, right? Okay, good. So not much challenge here. There's no messy rule, but we do have to worry about the cleanup here. All right, so I do see a little bit of cleanup that I can do before I decide what to do next. I'm going to worry about that too. I'm going to take care of that too. Anything that I see that I can move to the right side, even if it's a small thing, I'm going to go ahead and do it. It'll just make things easier down the road. So distribute 2 through everything. 2's cancel out. Y squared equals distribute 2 through 2x squared minus 2x plus 2c, but we know 2c is just a constant, so we can just say plus c. Okay, so we know we got to solve for c, we know we got to solve for y. Okay, which order should we do this in? Which will make it a little cleaner for us?
Would it be c first this time because of the y squared?
Yeah, I prefer to solve for c because I know that there's a square root coming, and I want to solve for c before that square root comes in. If I wait to solve for c, then I got to deal with the square root, and it just makes it messier. So I'm going to get to that c before that radical shows up. So yeah. So I'm going to plug in -3, 6 in for x and y. That allows me to solve for c. Get that resolved, and then when when the square root shows up, I don't have to worry about dealing with what's inside that square root. I can leave that to be the last thing I do. Okay, so -3 goes in for x, 6 goes in for y, and I can solve for c here. Okay. Multiply everything throughout. 2 times 9 is 18. Right, 36 equals, okay, subtract 24 from both sides. I get 18. Oh, sorry, 12. Okay, so now that I have my C value, I'm going to go back, update it where I initially started my substitutions for my x's and y's. Okay, so that leaves me with y squared. And now we can bring in the square roots, and there's no need to deal with anything afterwards because we've already got that 12 result. Okay, square root, so we need what in front?
Plus or minus.
Yeah, plus or minus. Okay, but we have to understand that these are two potential solutions, but only one of them will fit our criteria. And how do we decide between these two here? What's going to help us decide between these two options?
Would it be the positive one because 6 is positive in your interval? Or yeah.
Yeah, exactly right. The order pair is going to help us. If I put a -3 in, I got to get a 6 in return. The only way I get a 6 in return is if my y value is positive. So yeah, we're making that decision based off of our order pair. And what we're looking at is not the full order pair. We just want to look at the y value. Right? The y value is driving that decision. A positive y value indicates positive square root. Okay. All right, any questions with the process? Anything you want me to clarify or go over again? Okay. Okay, let's try this one here. Number 2 on this worksheet. Okay, what's the particular solution for our differential equation? With the initial condition. All right, so cross multiply just like before, right? Okay. The nice thing about cross multiplying is at least I have my dy dx's locked in. I know that those are good to go. Those are in their right slots. We just have to worry about the x and the y and decide, do we need to move anything else to get full separation? Okay, what do you guys think? Do we need to move anything else?
Would you want to move the y over to the left side?
Yeah, we want the y's on the left, x's on the right, so that's kind of sticking out like a sore thumb, right? When you bring that y over to the left, yep, divide by y. Okay. It's okay to have y in the denominator. We have rules that can handle that. Don't just bring that y back up to the numerator. This is where it belongs. All right, full separation. I think we're ready for our integral step. Okay. Left side, what's the rule for 1 over y?
Is that the natural log one?
Yep, that's right. Just natural log. Yep. Okay. Natural log absolute value of y. Okay. Right side is just power rule. And don't forget plus c. Okay, I see natural log. That's going to cause me to want to wait before I solve for c. So I'm going to clean this up before I solve for c here. Okay, so I want to solve for y to begin with, get to my cleaned up general equation. So I want to undo that natural log, so raise both sides with e as the base. So this cleans up, right? Cleans up to be just that's the value of y. Okay, split this up. Okay, e to the c, we know what happens there. That's just a constant. Okay, push that constant in front. We can also drop the absolute value at the same time. Drop this plus or minus because the c is just going to suck that in. Okay, we have a relatively clean equation. Now we can work in the order pair. Okay, so we'll put e in for y, 3 in for x, but you see that it's not going to quite clean up as nicely as before, but we'll just kind of see what this gives us. That's going to leave us with 27 over 3, which is 9. So e is equal to c e to the 9th. Not going to clean up as nicely, but we'll just keep track of it. Divide both sides by e to the 9th. Okay, what can I reduce this down to be?
Would it be e to the -8?
Yeah, either 1 over e to the 8th, or you can bring it up as e to the -8. Either is fine. Okay, either way, we know what to replace our C value with. This is perfectly fine, but because you have the same base, you can write the base once and just combine those together. Yeah, usually we're used to seeing the E just go away to just be 1, but in this case, it looks like we just have to keep track of our leftovers. And even if you don't clean this up, if you left it as E over E to the 9th and you left it as one big mess, I wouldn't take off any points. But I think it is helpful to know what the simplified version looks like, just for future reference. If you're trying to find, if it's a multiple choice question and you're trying to find the matching pair or the correct answer choice, it's nice to know a couple of different versions of the answer to make it easier to select the answer choice, because sometimes the answer choice on a multiple choice question may not be the one that you arrived at, and sometimes you may have to kind of play around with your form to get it to match the answer choice given. Okay, any questions here? All right, this is from the back of the handout. These are all kind of given on different days, and so that's why the numbers looks like they're duplicated. Okay, this one here. Okay, y prime x natural log of x minus y equals 0. Solve, find the particular solution given the order pair E comma E. Okay, so what can we do first here?
Separate x and y.
Okay, separate x and y, we can do that. What else? Is there anything that we need to rewrite?
Could you make y prime dy dx?
Yeah, let's
Or
do
not?
that.
Okay.
Let's do that. Yeah, dy dx. But I'm going to just go ahead and merge them into the same fraction. I can kind of speed up that process of getting to that cross multiplying portion where I can get at least the dy and dx's kind of locked into their places, even if I may not get full separation, but you know, we can take our time with that. So cross multiplying looks like a mess, but we're about to at least have our dy and dx in the right places. Okay, so at least we have those in the right places, right? dy is good, dx is good, but quite a few things out of place, right? So what needs to be moved?
So would the y on the right have to go to the left side?
Mm-hmm. What else?
And then would the x natural log of x have to go to the right?
Yeah, they're going to have to end up swapping places, but both, as I move both of these, not only are they going to swap places, they're going to both end up in the denominator of the other side. All right, so it's going to look a little strange, but we do have rules that can manage that. But yeah, exactly right. I'll divide both sides by y, but then at the same time, I'll divide both sides by x natural log of x. They're just going to end up swapping places. Right, it looks strange, right? It looks like that we did something wrong, but we know that we're in the right track. If these are in the right spaces, it's okay to have x's and y's in the denominator. We can move forward. We can handle these types of problems. Okay. All right, let's reset and rewrite this. Okay, so left side is pretty straightforward, right? Jump directly into the natural log rule. But the right side, yeah, the right side is more complex than that. Okay, what do you think we can do on the right side? Any ideas?
I'm not sure if this is correct, but could you make x ln x a u value?
That's so we definitely have to go with the U-substitution. Okay, let's think about that. All right, so if our U value is x ln x, what's the derivative going to be? These are two separate problems, so the derivative would have to involve. This is product rule here. And product rule, f prime g plus fg prime, that's going to leave us with an extended expression where we have nothing to pair it with. So I think this is a little too much. Okay, it's a little too much because the derivative of x ln x is not just going to go away to just a constant, and there's nothing to help us pair that with. So, but it's a good start. We definitely need a u value. We definitely need to go through U-substitution. What's another potential u value that could make this work?
ln x.
Yeah, let's think about this one here. ln x. We know the derivative for natural log of x is 1 over x, and hopefully with that derivative, this x can be managed, right? So we know that's a better fit than just using x, right? If we let the x be the u value, then we're left with 1 over u ln u, and there's no rule that can handle 1 over u ln u. So, and also we never want to let the u value be just x. If we do that, that means we haven't made any progress. We need to let the u value be a significant portion. This is a little too much. It's a good guess, but it's a little too much. So we pare it down a little to, let's try that ln x. Okay. All right, so. Okay, our derivative, du dx, is 1 over x, cross multiply. Okay, cancel the x's out. Okay, we're left with 1 over u du. And it looks like both sides will be natural log, right? This one, after U-substitution, the left side is just in terms of y. So we're ready to handle both sides. So this becomes natural log absolute value of u. And I can bring that u back in terms of x. All right, there's our initial general equation. There's still more things we can do, but you've accomplished most of what I want to see by getting to this point. Okay, I'll put a box around this because this is it's a good indication of you earning most of your points from at this stage of the problem. All right, so we want to solve for y, we want to solve for c. Which order should we do this in?
Would it be y this time because the y is not squared or anything?
Yeah, I like to target the y. I know that the c is going to help clean this up. It looks a little strange here, but it'll be a little cleaner at the end than it is here. So I'm going to solve for y. Okay, raise both sides with e as the base. So this becomes absolute value of y, e to the natural log of x times e to the c. E to the c just becomes a constant. Pull that constant out in front. Drop the absolute value. And we can actually do a little bit of cleanup here. You see that e and ln, these are inverse functions. We can just make them cancel out, and that's going to drop that ln x directly down. So we can take those out, drop that natural log, and then we can also drop the absolute value because the c can absorb that. So the c can do a lot for us here. Okay, I'm just using parentheses here. But we're literally just dropping both sets of absolute value and then just let c absorb all the plus or minus that can come from that. So it looks strange, but we have a simpler equation. From here, this is where I like to solve for c. Okay. E for x and e in for y. Okay. We know what happens with natural log of e. That's just equal to 1. C equals e. Okay. So now I can update my equation. I know I'm targeting that c, so I'm going to rewrite it. There we go. There's my general equation. I solve for c, and now I'm just updating it. Okay, any questions so far? Okay, let me pull one that is not in terms of x and y. Let me find one here. Sorry guys, give me one moment here. Okay, here we go. Let me put this directly in the chat box in case you want to follow along, or yeah, the key is also attached to it, so. Okay. Okay, let me do a tough one for with you here. This showed up on the AP exam. I don't know. I would say about 5-6 years ago, and this was before I really focused on problems that did not deal with X and Y. And I feel like I'm giving a lot more emphasis now, knowing that they like to potentially put non-X's and Y's on the AP exam. So I want you to look at this one here. Oh, this is number 4 off that handout. That's okay. So okay, so dg over dt equals negative parentheses g minus 27 to the 2/3. But you know, we've been kind of seeing this couple times, not as much as X and Y's, but we kind of know the pattern now, right? We know that, all right, this is strange, but we know the T's is going to be on the right, and then the G is going to be on the left. So start off by cross multiplying, get our dg and our dt in their right spots. Okay, so what do you see out of place? At least our dg and our dt are good, right? These are good to go. Okay. What's out of place that we can move?
Would you want to move the g to the minus 27 to the 2/3 to the other side?
But what do you want to? What should we leave on the right side?
Would you leave the negative sign?
Yeah, leave the negative sign. Yeah, because the negative, it's like a -1, right? Doesn't have to be on the left side. I mean, we can move it, but there's no need, right? We only need the left side to be what absolutely needs to be there. Leave it on that left side. So yeah, let's just move the parentheses in the 2/3, but the negative, there's no need to move that. Okay, full separation, right? G's on the left, T's on the right. But what do we have to involve on the left side? Let me make this maybe hopefully easier for you to see. All right, what's involved here?
U-Substitution.
Yeah, U-Substitution. Our U value is that G minus 27. Okay, I'm just bringing down the right side here, but okay, how do we handle this 1 over U to the 2/3? What rule do we use? Okay, what do you guys think? Can we use natural log?
Can you move it to the top?
Yep, we got to move it up and do power rule, right? We only use natural log if this is u to the first power. If it's any other power, it's got to come up and it's got to be power rule. Okay, add 1 to the exponents. Okay, so we took the antiderivative. We still need to replace the u back in terms of g, but how about the right side? What? Because I waited for the left and right side, so we can just take the antiderivative all at once. What is negative 1 dt going to turn into?
Negative t.
Good. Plus
Plus c.
c. Okay. So this 1/3 is really a 3, right? So I'm going to reset, put that up here, and also going to replace the u back in terms of g. All right. The good news is you've earned most of the points here. You found the antiderivative plus c. That's great. The rest is messy, but the points is not as much. Okay. So I am okay. So I'm gonna divide by 3 first. There's no cube roots, but I think that if I can cube both sides first, maybe I can wait till the end to solve for c. So cube both sides, that will get rid of that 1/3. Maybe on second thought, maybe I should have solved for c a little earlier, because even though there's no cube root, there's a cube here, which could make it a little messy. Let's see what happens though. Okay, order pair 0 and 91. Okay, 0 in for t and 91 in for g. 0 plus c is just c over 3 cubed. Okay, 91 minus 27. Okay, cube root. So c equals 12. We'll go back, update our equation where we initially made that substitution. Right, that's a mess. However, the important part is being able to get to this point. Doing the U-substitution, doing power rule, getting up to this point here. I know this is messy, but if you saw this on the AP exam, all this, maybe this is like a 5-point question, and then everything up to this point is like worth 4 points, and then the rest is like worth 1 point. So, you know, doing all that work for 1 point, but then at the same time, if you mess up, you're not going to lose that much either. So, okay, so this is algebraically messy, but the emphasis is, can you get to this point? Does this make sense here? Getting all the way down to the antiderivative. Okay. All right, do you guys have any questions? Are there any other ones you want me to go over with you? Okay. All right, so tomorrow, I'll have a help session tomorrow morning and afternoon, and I'll probably spend that time maybe going over some slow fields. Maybe I'll go over more like U-substitution problems, and maybe I can pick out some problems from the worksheet 2 and 3 that we're not going to cover in class. So, all right, thanks for being here, everyone.
Thank you,
See
Mr.
you guys
Yang.
tomorrow. Thanks.
That's Thursday, right?
Mm-hmm.
Mr. Yang?
8 to 10. 1 second.